Section 6.16 asks, why exactly do we use energy? What exactly are the benefits? And there's a couple of reasons we do it. One fact, it puts limits on what actions can happen. It lets us know, for instance, how far apart particles are going to get. Are particles bound together? And this comes about because of conservation of energy. It really gives us a very powerful tool for figuring out what motions are possible, which ones aren't possible. Another really useful feature is that we're dealing with scalar equations. And from spending the past few chapters dealing with vectors, you can kind of appreciate the simplicity of dealing with scalar quantities, not having to worry about components. The drawback is that we do lose a lot of detail. So when we're using energy conservation, even though we might be able to figure out the speeds quite easily, we can't actually find the velocities. We can't find the vectors or directions of our velocity from energy. And so this simplicity, this power that energy brings, does come at a cost of not being able to figure out exactly which way things are headed. The last section, 6.17, really brings everything in this chapter together. And I'm not going to say a whole lot about this, but I am going to encourage you to go through the two examples in this chapter in some detail, because it shows all the different things that we've covered up till now. One thing I do want to encourage you to do that the text doesn't are using the energy bar charts. So with the energy bar charts now, we need to consider, if we have changes of identity, we have to consider the E rest energy. We're going to have K initial, we have U grav initial, we have U electric initial plus work. This is going to be E equal to K final plus UG final plus UE final plus E rest final. And so you can draw in the energy bars for these different things. And if any of these terms have a zero, you can just leave them out of the equation. And so you'll be able to write down your energy conservation equation right from this. This is a very useful visual tool for calculating energy problems. One thing to keep in mind is that if the particle doesn't change identity, if you have the same particles in the beginning and the end, you can drop out the rest energy term. It doesn't really affect things, and in fact the rest energy tends to be large compared to a lot of the other parts of the system, so your energy bar chart would have to go off the page in real life. So make sure that you're using these energy bars and try to work through the examples in this section, and I'll show you how to kind of bring everything together.